So let's start with structural pattern matching in Python. Well, some will claim that it is actually kind of an improved version for the simple switch statement we all know from other programming language. However, few will claim that it is about something else, and I will leave it to you to decide whether to adopt the definition for pattern matching as a switch statement on steroids or not, or look at it in a different way. So let's start with a simple example for pattern matching. This code sample shows a very simple pattern matching, very similar to a switch case statement we know in other programming languages. As you can see, we have the keyword match, and then we have an expression. It can be a variable that holds a value, holds a reference for a specific object. And then, as you can see, that value is compared with each one of the cases. And the case that match is the case that is executed. So this is a very simple demo for pattern matching, very similar to switch case. I just want to verify. You see my screen. I'm correct?
Yeah, we can see.
Yeah, okay. Let's move forward and see more sophisticated pattern matching we can implement in our code. For start, let's talk about the wildcard. We can use the wildcard in multiple ways. For instance, we can use it as a default option. So here in this code sample, we have the variable command. It has a specific value, and then that value is compared with each one of the cases you can see. And the wildcard is kind of a default. So if none of the other cases match, then the wildcard takes place. We can use the wildcard in different ways, and we shall see that shortly. Now let's see the possibility to compare a sequence. We have a sequence that holds values, and we compare it, and we have different cases. And in this code sample, you can see a comparison that is based on the number of elements the sequence has. So we have two tuples. Eventually, this is the tuple that we find that is compared to the cases. And as you can see, the tuple has 1, 2, 3, 4 elements. So the question is whether it matches the first case or the second case. So the first case has only 3 variables, so it matched the second case, and operation is assigned, is kind of a variable that is assigned with transfer, sum is assigned with 800, from ID is assigned with the number 1, 2, 3, 2, 2, 2, 2, and to ID is assigned with 101, 888. So in this very simple code sample, we see a comparison, we see try to match an expression to specific cases based on the number of elements the sequence holds. This is a very simple matching. Let's take a look at this code sample. Here we have, as you can see, each case has some variables, but it also has some values over here. So when comparing this sequence, in this case it is a list, to each one of the cases, then first there is a try to match the first value to the first value we have in each case. So this case doesn't match, this case doesn't match, this case match, because we have the string playing over here and over here. Then the second value is assigned to the variable gain. Whatever you see in a case, each case actually refers a specific structural pattern, and the structural pattern can be composed of other patterns. Those other patterns can be a wildcard, they can be specific value, and they can be kind of a variable. So these are the possibilities. So in this case is the one that match the sequence we have. Now let's move forward and see something more sophisticated. Let's say that we have a sequence of multiple values. As you can see, the star we had over here serves as kind of a packing operator. So when comparing this expression to each one of the structural patterns each case refers to, this structural pattern match this expression because the first value is the string delete, and this is exactly what we have over here. Then all other values are packed, and files is assigned with the reference for a sequence that holds those other values. If we pause our progress of moving over the slides and think about cases in which using structural pattern matching can be useful, then one option, for instance, is one scenario, for instance, is when you develop a utility, a standalone application, a utility you execute through the terminal, and you pass over values, multiple values. Using structural pattern matching, we can express what exactly we want to happen in when the first argument is delete, when the first argument is copy, when the first argument is another command, and then all other values, having them packed in a sequence makes it very simple to extract them from that sequence and use them according to the first value of that sequence that was compared to using a match statement to specific cases. Let's move forward. So we can see that structural pattern matching is actually a composition of other patterns, and we actually have the wildcard pattern, as we said before. We have the literal pattern, which is actually a string, for instance, or another value, and we have capture patterns, which is actually about having variables that will be assigned with those specific values that match them, those specific values the expression includes. Now, over here, we have an expression. That expression, its value is a reference for a tuple object, the tuple object that includes 1, 2, 3, 4, 4 elements, 4 objects. So when comparing this specific expression to each one of the patterns the cases refers to, then first there is a try to match the first value. So the first value is a specific string, and it matches this specific string. Then, as you can see, this tuple is compared to this pattern, and because of that, we can expect having Moshe assigned to student name and the number 234 assigned to student ID. Then the rest of the values are assigned to the other variables. So 103444 is assigned to course ID, 88 is assigned to mark. So again, we can see a pattern composed of other terms, and those patterns can be a literal pattern, this one, or a capture pattern as this one, and this one, this one. Let's move forward. We can use the OR operator in order to create a structural pattern that actually includes several possibilities. So for instance, in this case, we can say that there will be a match to this specific case if there is a match to at least one of the small patterns, small structural patterns we see over here. So in this case, we have a tuple with two strings. So it matches actually this pattern, and because of that, the string temp.txt is assigned to file, and then something happens. Again, just imagine that you develop a utility that when executed, we pass over specific values to it, and those values we pass over include a command and other values. And that command, let's say we want to allow using the word del or delete or remove, we can easily achieve that by using the or pattern as we can see over here. So this will be the output. Let's move forward. Using the S keyword, we can actually create a variable that will be used in our code. Here, for instance, this specific case refers this pattern, and as you can see, using the OR operator, we have a pattern that when we compare it to a specific string, it is enough that the string will be one of those that is mentioned over here. And in this case, we have a match between this string and this one. And using the S keyword, we actually get the variable we place right after assigned with that specific value that is one of these three. So the variable command is actually assigned with the string del, and file is assigned with this string. Okay, so then we can use that. And again, just imagine about developing a small utility that when executed, we pass over arguments, which are actually commands and other values. And according to the argument we pass over, something happens. Okay, we can even use a condition like the if statement, and we can say that this pattern, if there is a match between the expression we use with this specific pattern, then that match will be a match that is considered as a true match only if the condition right after is true. So in this case, when we check if file in files, we actually check if the file, which is the second value, is one of the files we have in a specific list or in a specific iterable object. So using this if condition, we can turn the pattern matching into something even more sophisticated. Now, it seems that we can use structural pattern matching to avoid detailed code that check the type of specific object we have. We can avoid the use of easy instance by simply using a match statement that compare the object to specific objects created from specific classes. So in this case, for instance, OB is a variable that is assigned with cat. So OB is assigned with reference for an object instantiated from cat, and then it is compared to these patterns. So the first case is false, of course, because we have an object instantiated from cat, and here we have an object instantiated from dog. And then there is this case and this case. This case is, of course, false, but when taking a look at these two cases, you can see that over here, we actually create an object of the type cat with a predator assigned with false. Here, the same, only that predator is assigned with true. So the question whether the match happens between OB and this pattern or this pattern is actually a question of what is the value of predator in that specific cat object OB holds its reference. So if we go back, we can see that OB is assigned with a reference for a cat object that predator, an attribute that object has, is assigned with true. So in this case, we can expect to have a match with this pattern, which means that we can expect having this code executed. And as you can see, this is indeed the case. So we can use pattern matching for comparing an object with other objects, and that comparison starts with comparing the type. And once the type is the same, there is another comparison of the values of that specific object holds with values that each one of the other objects hold. Now, if there is only one value, as in this case, we can simply do what we did over here. So we can compare an object from the class cat with this one and this one. And because the predator attribute holds true, this is the pattern that match. Now, if we have more than one attribute, there is still something to do about it, and we shall see that shortly. If, for instance, we have an object that was instantiated from a class that was marked as a data class, or an object that was instantiated from the class tuple, in those cases, we can easily expect that there is a specific order for those attributes the object holds. So we can easily compare an object that was instantiated from a line with other objects instantiated from line, as this one. Well, in this case, we have only one. And when doing this comparison of this object to this object, the order of the attributes is maintained and is in accordance to the way the attributes are shown in the definition for the data class we are using. So over here, we actually have an object instantiated from the class line that holds two references for 2 point objects. So when comparing that object to using the match statement to this one, we can expect having the reference for this point object assigned to P1 and the reference for this point object to be assigned to P2. And we can, in this case, do something, as you can see here in the code. Well, the second case is not relevant because OB holds a reference for a line object, and the second case is use a point object. So of course the match doesn't exist. Let's move forward. Okay. Now, what happens if you are using objects instantiated from a class that wasn't marked as a data class? In that case, there is still something to do about it. We can simply add to the class definition for the attribute match args and assign it with a reference for a tuple that holds strings which are actually the names of the attributes every object instantiated from that specific class as. And this is our way to say this is the order, this is the way the comparison will be carried. So in this case, for instance, we have the class point, we have the class line. Both classes have the match args attributes that specify the exact order. And then when you instantiate a line, get a line object that holds two references for 2 point object, and try to compare it to those structural patterns. Well, of course, the second case is not relevant because OB holds a reference for a line object. So based on the types, the second case is not relevant. It can't match. But when comparing to this object, we can expect having P1 to be assigned with the reference for this object, the object that was created over here. And we can expect P2, the variable P2, to be assigned with this object, or to be more precise, with the reference for this object. And when that happens, we can use those two variables P1 and P2 and do something with them. As you can see in this code sample, where I actually calculate the length of the line and print it to the screen. That's all. Okay, let's move forward. We can use pattern matching when working with enum. If you have a definition for an enum, it's actually a definition for a class. So if, for instance, you have an object that was instantiated from the class car, and that object has 3 attributes, and the class car, of course, includes the definition for match args. That allows us to compare a car object to specific structural patterns we have over here. So when comparing that car object to each one of these structural patterns, the comparison of the value of this expression, which is actually a reference for an object of the type color, is actually a comparison with a color object that represents white. And I just want to remind you, color is a class, a simple class, but it was defined as a class that extends enum, which allows us to use those specific values. And when we specify a color that blue or color that white, this is a specific value. So over here, you can see that it is possible to compare color green to color white, color black. In this case, the first two cases fail, but then we get to the third case, and the third case as a match. And the string Mazda 6 is assigned to car brand. The number 2342343 is assigned to car ID, or if you want to be more precise, car ID is assigned with the reference for the object that represents this specific number. And eventually, over here, we have a wildcard. So anything we have over here match. And that's why the third case is the case that match the expression we have. Now, we can also use pattern matching when using dict objects. For instance, over here, we have a dict object with two key value pairs, and when comparing the value of command all the reference for a dict object to each one of the patterns we have over here. Well, the comparison is very simple. We have the two keys, action and account, which means that the first case actually match. The comparison is done based on the name of the keys. And later over here, only if the value of the key action is the string get balanced, then we can say that we have a match over here. And regarding the second key, over here we actually have a variable, so no matter what the value of the account key, a match exists, and the variable account in this case is assigned with a reference for this small dict object. So eventually we have a match over here. Over here we don't have a match, of course. Let's move forward. If we have dict object with multiple key value pairs, and we are interested just in the first key value pairs, as in this case, we have the keys action and account that we also have over here. The rest of the key value pairs are packed to a dict object that OB is assigned with reference. So later we can use that. In this case, print OB, meaning getting the rest of the key value pairs printed to the screen. So when having a dict object that includes more key value pairs than what we see in the pattern, we can certainly have the pattern including another variable marked with 2 stars, and that variable will be assigned with the reference for a dict object that includes all other key value pairs that are not shown over here. So the bottom line, the dict object you have when comparing it to a specific case, that dict object can have more key value pairs than what we see in the specific case. And all of those other key value pairs will be packed as a dict object that its reference will be assigned to the variable we specify over here with 2 stars. Okay, we can use built-in types for validating the types of specific parts of the expression. For instance, in this case, we have the variable command assigned with the reference for a dict object, and that dict object has 1, 2, 3, 4 key value pairs. The first key value pair is actually the key action, a string, and its value is another string. And over here, you can see that I used the function str, which is actually the name of a class, just to add one more check, one more validation check to verify that the value of the key action, as you can see, we have the key action, it has a specific value. That value, in this case, get balance, is assigned to the variable action. Using this code snippet, we actually verify that action is assigned with a reference for an object of the type str. This is another layer of validation we can add to the pattern matching. Okay, so that's it. And now I'm open for questions you might have, and I'm with you. Yes, please.